So let's continue on with part 3. Part 3, we are told to rotate this about the y-axis, two right angles. Two right angles meaning 90 degrees times 2. Same thing with what we did with the previous part, which is we just need one. We don't need the full rotation. So if you could see, is something like that, just 180. Revolve about it is just half of it, right? Yeah, but I could model it out for you. So this is important because this is something which I think sometimes students get confused. There's a cylinder involved here. So I'm gonna just quickly rotate and show you. So if I were to rotate this about 180, about just 180. Okay. Whoa. Okay, let me see. 180. Okay, yes. 180 will mean that actually you're going a full 360 degrees, right? Because this what do you call it? You could see that as you rotate 180 of it, it becomes a 360 diagram like that. I'm not sure why this is rugged, but yeah, you get the idea. So there's this dent here that you need to minus off. Okay, so I need to explain part 3. Volume generated. You need what do you call it? To minus off this portion here. Okay, this dent here is important, so that it will you take the cylinder. Okay, cylinder here. Minus off the top part, which is like the small dent on top, if you can visualize it. Okay, so I hope you can. This would be 1 unit. Then this will be a height here, which is 1. This here you could find a height. So when x is 1, this is 1 over root 3. So obviously this is 1 over root 3 here. This is 1, and just sub into the equation y equals to 1 over 4 minus x squared, right? Yeah. So it's 1 over root 3, and after which, same thing. Okay, and this will be negative 1 over root 3 as well. Great. So once that is done, this part here, this cross section here will be 0 and 1 over 2. Okay, there's 1 over 2 there. Great. So what we need here is essentially taking this small dent here. You need to minus off this, because when you integrate with respect to y, this curve, you're actually getting this this portion here when you project on the y-axis. Okay, so this small portion here is a very annoying piece, which is this part here. So here, this is a cylinder. The outer, this whole thing is a cylinder. So I'm going to take the cylinder. Cylinder would be 1 over root 3 here. So this is 1 over root 3, of which the r is 1, which is here. Okay, and that's about it, I think. And after which we have got root 3. That's 1. Okay, so this would be pi r square, which is the radius, and the height 1 over root 3, minus of this would be pi from half to root 3, 1 over root 3, y square, x square dy. Okay, so I'm going to find out what's our x square, make x square the subject. So this will be square root 4 minus x square equals 1 over y. 4 minus x square equals to 1 over y square. X square equals to 4 minus 1 y square. Okay, so this is 4 minus y square. So pi root 3, 4 minus 1 over y square. Is it 4 minus, yeah, there you go. So this shouldn't be a problem, I think. I think should be fine. So this is y. 4y. Going to integrate straight. This is 4y minus y minus 1. Okay, so this case here, done. There you go. It's a lot of, oh my goodness, a lot of things going on here. So let's see how we can, we need it in root 3, right? So this is certs. I could just multiply bottom with root 3, top with root 3. I think it's not really an issue here. So this will be 1 over, this is root 3 over 3 pi minus pi 4 over root 3 plus root 3 minus 4 times half, which is 2 plus 2. Same with this. Multiply root 3, multiply root 3. I could get 1 root 3 pi. Be 4/3 root 3 plus root 3 minus 4. So this will be 7/3 root 3. Okay, maybe I'll factorize out the pi out. It'll be easier. 1 root 3. 4/3 plus 1 would be 7 over 3 pi root 3 plus 4. Okay, there you go. So the thing about showing question, I love it, is because you can check answer. So this is 4. Hopefully that's the answer. Yep. 2 root 3. Yes, correct. So there you go. 4 minus 2 root 3 cube units. Yeah, that's how you do this question here proficiently. Any question at all, please let us know. Keep practicing and I'll see you in the next question.